Peripheral devices play a crucial role in harnessing the advantages of a system as they facilitate input-output or I/O operations and establish connections between the system and the external world. Certain devices such as mass storage and networks serve a dual purpose by functioning as both input and output devices. These peripherals enable the exchange of data and communication with the system, allowing for seamless interaction with the external environment. In this video, we're going to delve into the architecture of input and output, exploring its characteristics, considerations, behavior, and more. Additionally, we'll examine its performance, including factors like speed. Like this segue to our sponsor.
Tipaneps! Get rid of your old mouse, try Tipaneps! This beast of a mouse is designed for ultimate precision and control. With customizable body and adjustable DPI, crush your competition with Tipaneps and elevate your gaming experience to a new height.
Broadly speaking, peripheral devices can be categorized into different groups based on their functions. Firstly, there are input peripherals that enable users to input data from the external world into the computer system. Secondly, output peripherals facilitate the transfer of information from the computer to the external world for display or further processing. Additionally, there are input-output peripherals that allow bidirectional communication by enabling data to be transmitted both into and out of the system. Another category is storage peripherals, which utilizes input-output operations for storing and retrieving information. These storage devices play a vital role in data management within the I/O framework.
Let's talk about the I/O characteristic. First, the behavior. Behavior refers to the action and behavior related to input and output operation in computing system. It involves the receiving input from user or external resource, generating output for presentation or delivery, and restoring data for later use. Input behavior includes the receiving data through devices like keyboards or scanners, while the output behavior involves the displaying or representing processed data through monitors or printers. Now, let's proceed to characteristic partnering. Partnering refers to the coordination or a synchronization of input and output operation in computing system. It involves the synchronizing input and output action, provide the feedback and response the mechanism, handling errors or validation, managing the buffering, enabling asynchronous event to driving communication. Effective partnering ensure the smoothness of communication between the system and the user. External device allowing for real-time interaction and accurate data handling and efficient data processing. Let's proceed now to characteristic data rate. Data rate refers to the speed or rate which data can be transferred between the input and output devices in computing system. It represents how quickly information transmitted or processed, typically measured in bits or bytes per second. A higher data rate indicates a faster data transfer, while the data lower rate implies a slower transfer speed. The data rates affect the efficiency and responsiveness of input and output operation, affecting the overall performance and the user experience system. Managing the optimization and the data rate crucial, ensuring the smoothness and efficient communication between the devices in the system.
Also, when we buy our input and output devices, there are things that we consider. Performance. Considering performance is crucial because it directly impacts our experience. Efficient and reliable devices can enhance our productivity. Expandability provides you with the flexibility to customize your computer system to meet your specific needs. For example, if you want to connect additional monitors for dual screen setup or add a specialized input devices for a specific task, having expandable ports or connectors allow you to do so without limitation. Cost. Considering the cost is crucial if you have a specific budget constraint. It helps you identify devices that meets your requirements while staying within your financial limitations. This is ensured that you can acquire the necessary devices without overspending. Lastly, size and weight. The size of device is important because it determines how much physical space they occupy on your desk or workspace. Choosing device with a compact design or smaller footprints allow you to optimize space utilization, especially if you have limited desk or storage space.
Now, according to this table right here, we can see the different kinds of devices, if it's an input or an output, the data rate of the said device, and the control of the device. For example, for the first part, we have the keyboard, which is an input device that has a very low data rate because it doesn't need a lot of data going inside to the computer, because it just needs to register what kind of keys that we are pressing. And the control is an external software. Now, in the second part, we have the mouse and the touchpad, and also the touchscreens. But mouse and touchpads are actually input devices with a low data rate, which is also has a control of an external. But the touchscreen is actually an input and an output device these days because a touchscreen monitor or touch screen actually outputs something. So it's actually an input and an output device. Now we have the scanner, which is also an input with a medium data rate, a microphone, which is also an input with which has a low to medium data rate, which depends on what kind of microphone do you have. We also have the sound, which is an input or and an output, where sound from the microphone goes into the computer, and sound from the computer goes outside using speakers. We also have the USB, which is also an input and an output, a network, which is an input and an output with a high to very high data rate. And we're gonna go to outputs. We have the printer, which prints out things from our computer, and a graphics display, which is usually a monitor or like a second screen, one of those touch tablets with a built-in screen on them, which also has a high data rate. Now, the last part, we have the flash drives, or the different kinds of disk drives. So we have from the flash drive, which is a storage type that has a medium data rate, the magnetic disk, we have just SSDs or solid state drives, we have optical drives with medium to high data rates, and lastly, a magnetic drive which has a low to medium data rate. As you can see, there's more devices that we can talk about, but these are like the main components or the main I/O devices that we usually have on our computers.
We will talk about the I/O performance and its parameters used in checking the performance of each I/O device or controller. So first, what is I/O performance? I/O performance measures the efficiency of data transfer between storage and the computer's memory. Example, transferring a 1 GB file at 100 megabytes per second. So let's talk about the parameters used in checking the performance of each I/O device or controller. So first is I/O bandwidth. I/O bandwidth measures the amount of data that can be transferred per unit of time. It indicates the speed at which data can be read from or written to the device or controller. Bandwidth is typically measured in bytes per second, megabytes per second, or gigabytes per second. So the next parameter is I/O latency, also known as response time. Measures the time taken for an I/O operation to be completed. It concludes the time spent on processing the request and the time spent on transferring the data. Lower latency indicates faster response time and better performance. So for example of these two parameters, imagine you have two different solid-state drives for your computer. SSD-A has a higher bandwidth of 500 megabytes per second, while the SSD-B has lower bandwidth of 250 megabytes per second. However, SSD-B has a significantly lower latency compared to SSD-A. In this scenario, you need to transfer a large file such as a 10 gigabyte video. SSD-A would complete the transfer faster due to its higher bandwidth. It would take approximately 20 seconds to transfer the file at its maximum speed. On the other hand, if you need to access small files frequently or perform tasks that requires response time, SSD-B would be more suitable despite its lower bandwidth. This is because the lower latency of SSD-B would result in faster access times and reduced delays for individual I/O operation. So the choice between SSD-A and SSD-B would depend on your specific use case and whether you prioritize faster overall data transfer or bandwidth or faster individual I/O operations or latency. In conclusion, I/O performance evaluates efficiency, bandwidth measures transfer rate, and response time quantifies completion time. Understanding these concepts helps optimize performance and ensure smooth data transfer.